This is the third and almost certainly the last episode on the fetch method. Today I want to go over some advanced aspects of using fetch. First of all, it's worth noting that while up till now I've demonstrated it in the context of hash objects, fetch isn't limited to hashes. It's also available on arrays, where it behaves very similar to the hash version, except that when the key is missing and no default block is supplied, it raises an index error instead of a key error. You can also find fetch on the env pseudohash. I find this very useful for optional configuration values, for example, enabling a port number to be customized via environment variable, while still providing a default value. Sometimes you want to get optional values out of a nested hash. Not only do you not know if the values will be present, but you don't even know if the nested subtrees will be there. For instance, here's some configuration data. I like to handle data like this by chaining fetch statements together, with empty hashes as the default values for missing subtrees. One thing I haven't yet shown about fetch is that it yields the missing key that was passed in. Here's some code that demonstrates what I mean. One scenario where this could be useful is if we have a lot of calls to fetch, which should all handle a missing key the same way. We can define the default block as a lambda taking one argument, and pass the lambda to each call to fetch. This code prompts the user for missing values. If you're already familiar with the fetch method, you may be wondering why I haven't used the two-argument form in any of these videos. For those who aren't familiar, instead of passing a block to fetch for the default value, you can pass a second argument instead. This avoids the slight overhead of executing a block, at the cost of evaluating the default value whether it is needed or not. Personally, I never use the two-argument form. I prefer to always use the block form. Here's why. Let's say we're writing a program and we use the two-argument form of fetch in order to avoid that block overhead. Because the default value is used in more than one place, we extract it into a method. Later on, we decide to change the implementation of default to a much more expensive computation, maybe one that has to communicate with a remote service before returning. When the default is passed as an argument to fetch, it is always evaluated whether it is needed or not. Now, our expensive default code is being executed every time we fetch a value, even if the value is present. By our premature optimization, we've now introduced a potentially much bigger performance regression everywhere our default method is used as an argument. If we had used the block form, the expensive computation would only have been triggered when it was actually needed. Okay, enough about fetch. Happy hacking!
Hi there, I'm Avdi. I'm the creator of Graceful.dev. If you enjoyed the video you just watched, I want to tell you there are a lot more where that came from. Here on the YouTube channel, we regularly release new freebies from the Graceful Dev archives, so hit that subscribe button and make sure you don't miss any updates. But our YouTube channel is just a taste. Over at Graceful.dev, we've got hundreds of videos like this one. From our unparalleled coverage of the Ruby programming language, to testing and refactoring strategies, to practical skills with tools like Git and Docker, we've helped thousands of programmers grow their programming practice and level up their careers. So if you're ready for more, come check us out at graceful.dev to get access to our complete and constantly growing catalog of courses. I hope to see you there.